Welcome to the last lesson under this topic. We started with atoms, the structure of atom, the atomic theory. We look at isotope and the effect of isotope on the atomic mass of an element. So lastly, we look at the electron configuration. Don't forget that we mentioned one of the subatomic particles that is revolved around the orbit of the nucleus of an element, which is electron. Alright, we'll be looking at how to write electron configuration, filling of atomic orbitals, and representation of electronic configuration of an atom. Let's get started. Alright, the electron configuration of an element describe electrons, how electrons are distributed in its atomic orbital. It shows the position, the location of electron in the atomic orbitals. Electron configuration of atoms follow a standard notation in which all electron containing atomic subshell are placed in a sequence. For example, the electron configuration of sodium is 1s squared, 2s squared, 2p6, 3s1. Right? The importance of electronic configuration. It is used to determine the valency of an element. That is used to determine the combining power of an element. It is used to predict the property of group of elements. To know the group trend, the electron configuration shows the group trend and the elements that have similar property with that element, and it is good for interpreting atomic spectra. Alright, writing electronic configuration, we make use of the shell. Now in lesson 2, I said the maximum number of electrons that can be accommodated in a shell is based on the principal quantum number, and it is represented by the formula 2n raised to power 2, where n is the shell number. Now, the shell values of n and the total number of electrons that can be accommodated are tabulated below. Do I have the table? Alright, I didn't put the table, but let's look at the electronic configuration. Number of electrons per level. For 2 electrons, that's the orbital name is K and the energy level is S. For 8 electrons, the orbital name is K and the energy level is sp. So which means if you have 2 electrons, it can only stay in the K orbital and the sub-energy level only on S. If you have 8 electrons, it will occupy the K and L orbital, and in sub-energy level that will be sp. For 18 electrons, that is M, which is spd. 32 electrons, that is N, which is spdf. And subsequently all other follow suit. Alright. Rules for filling of atomic orbitals. Apart from the rules, I tell you that filling the electron shell, 2 electrons for the first shell and all subsequent shell, 8 electrons. We have rules for filling the subshell orbital. We have the Hofbauer principle that dictates that electron will occupy the orbital having lower energies before occupying higher energy orbital. So the lower energy must be occupied before the higher energy orbital. That's the Hofbauer principle. Then the second rule is Pauli exclusion principle, which states that a maximum of 2 electrons, each having opposite spin, can fit in an orbital. So the 2 electrons in an orbital, one will face the upward direction while the other will face the downward direction. But according to Hofbauer principle, the lower energy level being filled before, you will have to fill the S sub energy level before the P. And in the orbital, you have to fill the K before the L before the M. That's overall explanation of Hofbauer principle. And the In's rule, it states that every orbital in a given subshell is singly occupied by electron before a second electron is filled in an orbital. So when you have an orbital, you have to fill it singly, that is facing in one direction first, then you fill the opposite direction. This is the order of filling electron. You have the n equals to 1, the 1s, 2s, 3s, 4s, 2p, and so on and so forth. So this give the rise to the 1s, 2s, 2p. Can you see the direction? 1s, from 1s, 2s, 2p, 3s. After 3s is 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s. Just look at the direction of the arrow. 4f, 5d, 6p, 7s, 5f, 6d, 7p, 8s, and so on and so forth. Alright, so that's the way to fill the electron. And according to those principles, filling the electron for this element now, this is the correct way of filling it. You fill facing opposite direction for the s orbital first, that's 1s, for the 2 s orbital level. Then for p, which has 3 different orbitals, this will contain 2, this will contain 2, this will contain 2, but you can't put the 2 here. Since it is the same sub-energy level, you have to fill it singly first. Fill this, if you have more electron, fill this, then you fill the reverse electron. This is absolutely incorrect, because you can't fill this up before you fill this remaining 2. You have to fill this singly first, according to Pauli exclusion principle. Alright, electron configuration. The atomic number of hydrogen is 1. Therefore, a hydrogen atom contains 1 electron, which will be placed in the s subshell of the first shell or orbit. The electron configuration of hydrogen is 1s1. That's 1s raised to power 1, as illustrated below. It's also illustrated here. You see only 1 electron in the shell of hydrogen. Let's look at another example. Let's look at oxygen with 8 electrons. Alright, the 2k shell which contain 2 electrons must be filled first, and the remaining seal into the L shell. You can see 1, 2 to the first shell, then we have the 1, 2, 3, 4, 5, 6 into the L shell. And the configuration is 1s2, 2s2, and 2p4. Alright, another example is chlorine, which comprise the KLM shell. The K shell contains 2 electrons, followed by S shell 8 electrons, that's 10. Remaining 7, because chlorine has 17 electrons, then the 7 must be filled into the M shell. And the electron configuration is written as 1s2, 2s2, 2p6, 3s2, 3p5. In conclusion, the electronic configuration of an element is a symbolic notation of the manner in which the electrons of its atom are distributed over different atomic orbitals. Please, the 3 rules that dictate the manner in which electrons are filled in atomic orbitals are the Hubble principle that talks about filling the lower energy level before the higher energy level, the Pauli exclusion principle that said they must be filled, orbital must be filled singly first, and the Higgs rule that tell us that when you are filling the electron, it has to be in reverse direction. One facing up, the other facing down. Please feel free to send your comments, your question, and every other thing, and make sure you attempt the assignment. I have attached a downloadable material to this lesson for you to enjoy. Thank you.